Hello everyone, welcome to this demonstration. In this demonstration I will demonstrate a project that I developed for encrypted network traffic classification in SDN environment. So here you can see all the scripts used for this project. So at first let me just run the Mininet topology using this topology.py script. So the command to create the topology is just the Python. We will just run this script using some Python command. So for that we need sudo privilege, and it will ask the password. So as you can see, the topology is started, and this topology has only one switch and these 6 hosts. So this is the Mininet CLI is already started, and there is no remote controller yet. So we will run when we will run the application, it will actually run it can contact to the remote controller. So by using this dump command inside Mininet CLI, we can see the process ID for each host. So we can see the process ID for each of the host 1862. So to create a bash for each of these hosts, we need this process ID, because we don't want to use the extram. We will create the bash for each of these hosts inside this tmux session, and for that let me just create a new panel inside tmux, and then by following this process ID is for host 1. So the command to start the bash for this host 1 inside tmux is mn.exec, and then with this a option we need to give the process ID of the host 1. So process ID is 1862, so we are giving the same process ID here, and then the program that we want to start for this host 1. So we need administrative password again. So yeah, now as you can see here, we are on the root of host 1. So this is the bash for host 1 now. And similarly, let me just create the bash. Let me open the bash for all other hosts, because in our demonstration we will generate traffic from host 1 to randomly selected host between host 2 to host 6 using a tool called D-ITG, and then we will run our RIO application that will monitor this traffic between every host, and then on real time it will classify those traffics. So let me open another panel, and in this panel by the same command I'll open a bash for host 2, which process ID is 1864. So 1864 and then bash. So by following the same command, we will create bash for other hosts as well. So let me open a new window in tmux terminal, and let me see the process ID again, 1866. So yeah, sudo mn.exec -a 1866 then bash. So it will open bash for host number 3. Similarly, this is for host 4. This is for host 5. now we will create another bash for host number 6, which process ID is 1872. So now we have the bash running for each of these hosts in different panels of tmux. Let me create another panel here. In this panel we will run the application, and that application will show us the real-time prediction of each of this traffic. So now the way D-ITG tool works is this D-ITG tool has actually sender module and a receiver module. So let me just open the directory for D-ITG tool. So inside this D-ITG tool we can see there is this ITG. We will use actually this ITG send to generate the traffic and send to a particular host, and this D-ITG receive module will run and will act as a receiver or as a server in the destination host. So in our case we will randomly select destination between host 2 to host 6. So this ITG receive module is needed to run in all of these hosts, because if host 1 generate any traffic to host 4 but ITG receive is not running on host 4, then it will basically show us the server is not running, or we will get error. So this panel is for host 1 and this is for host 2. So let me just run this ITG receive module here, and we are binding the IP address of host 2 to this ITG receive module. So the IP address for host 2 is 10.0.0.2. So if I run this command, and it is just waiting for traffic now. Similarly, we will run this ITG receive module to each of these hosts from host 2 to host 6. So this is host 2. Let me go to the next window and start ITG tool, then bin, and then here we will run this ITG receive module. And this is, if you remember, this panel was for host number 3, so the IP for host number 3 is 10.0.0.3. so similarly we will run this ITG receive module in each of the destination host, and we will bind the corresponding IP. So this is host number 4, and similarly this is host number 5, ITG receive, then bin folder, and then dot ITG receive, and the IP for it is 10.0.0.6. So now the ITG receive module is running in all of these hosts. Now we will run this D-ITG tool from host 1, and that tool will use a script, and that script will hold the command to generate traffic from host 1 to randomly selected any host between host 2 and host 6. So in our repository, code repository, there is a script that is named script generator.py, and by running this script we can create the script that will be used by this D-ITG send module to generate traffic. So what this script does, it basically selects a host randomly, and the number of flow is already written, so it generates commands for 20 flows, and the name of the script should be given here. So the name is script_1, let's say, and the IP for the destination is a list here, and it will select from this list randomly and that use that IP for the destination. And also the starting port number is 1000, and every time it creates a command to generate a flow, it increment the port number so that the port for the next command will be changed. So this let me just run this maybe, and then you will see what it generates. So the command to generate is just Python and then script generator. So this command actually generates this script 1 here. Let us see what is inside this script 1. So as you can see, there are commands, and each of this line in this file actually correspond to a single flow. So as you can see, the number of port and the time is also selected from a normal distribution from that script, and the time is sorted here. One important thing to notice here is this time in this script needs to be sorted in descending order. Otherwise the D-ITG tool will raise an error, runtime error. And the class is also actually this is the class. So we are generating 5 types of traffic in this demonstration. CSI means Counter Strike Ideal Player, and then VoIP, and CSA means Counter Strike Active Player traffic, and Quake 3 is another first person shooting game. So Quake 3 means the traffic will be generated from that game. So D-ITG tool actually emulates this game and generates the traffic for this game inside this environment, and also DNS traffic. So these 5 types of traffic will be generated, and as you can see, this is the destination IP address and destination port address. So these 20 flows will be generated at the same time from host 1 to these different hosts. So as we can see here, at a single time from host 1 to host 3, there will be 1 2 3 4 5 6 7 8 9 and 10 flows on different port. And our application, the Raivo application, will be able to distinguish between these flows based on the port number, and then it will be able to classify each of these flow, such as on 10,000 on 1001 the traffic will be classified as Counter Strike and Ideal Player, but on port number 1002 the generated traffic is VoIP. So let us see whether our app is able to classify these different types of traffic at the same time generated from host 1 to the same host 3 or other host as well. So this is the generated script, and this ITG send module here will use this script. So let me just copy this script to the ITG send module where this ITG send module is, so that here we can easily use this script. So we are just copying this script 1 to this D-ITG directory and then bin folder. So now we'll run the application. So the application is this app.py. By running this application, we will run the Raivo application actually, and this app will use this already saved model. This is the machine learning model we are using inside this script to classify the traffic flows. So the model is already trained, and the trained model is saved in this PTH file, and then this file will be used in inside this app.py. So now we want to show the output of the application in the terminal, and at the same time we want to save the output in a log file, so that later on using this runtime accuracy script, we can calculate what is the accuracy for our model, and also the inference time of our application. So for that we need to generate the save the output in a log file, and we have this script already, right? So we know what kind of traffic we are generating by this script file, and by that log file we will be able to know what is the prediction class for each of this traffic by the application. And this runtime accuracy.py actually compares these two file to calculate the accuracy of each of this flow. So to save the output of the application in a log file, we want to run using this Python command, but we want to specify this unbuffer option. Let me just increase the size of this panel a little bit. Now a little bit more maybe, yeah. So now this using this command and unbuffer option, the log file will save the output, and also we can see the output of the application inside this terminal. So the command is app.py, and we want to give the output of this application to this t command that will append this output to a log file, and the file name is log.txt. So before running this command, let me just verify whether there is any log file already here, because in that case it will append to that file as well. So yeah, there is no log file here, so yeah, we can use that command python -u app.py, and then we are piping this command with another command, that is t-a, that is for appending, and then log.txt. So if we run this command, we are getting some error here. Let's see, t is not defined. Okay, let me see the cause of this error. File not found, self-supervised. Okay, so I changed the directory, so that is why it is inside app.py. Okay, there is two paths, one is for the trained model and another one is for the monitor.py application. So let me change the path, desktop, and then the path is so the path for the application is encrypted network traffic classification in SDN. So yeah, I fixed these two paths, so it should be fine now. So yeah, but let me see, remove the log file, and then we can run this application using the same command again. So if we run this program now, we are seeing that the application is waiting for the traffic. We have to give the administrative password. Yeah, so now the application is actually waiting for the traffic. Now it's time to generate some traffic and see whether the model is able to classify it correctly or not. So for that we are going in the host1 bash, and here let's go to the D-ITG bin folder, and we already copied the generated script inside this bin folder. So the file name was script_1. So we will run this ITG send module and the script_1 file to generate traffic. And if we run this command, then we can see that all the 20 flows are actually generated at the same time. It is generating traffic, and at the same time you can see here the model is able to detect that flow, and the predicted class are shown here with this source and destination IP, and also the port numbers. We can also see the time for classifying each of this flow for inside this application. So this time inference time is in second, and the predicted class are also shown here. But by looking at this output, we cannot be sure whether this DNS or CSI, this predicted class, are exactly correct or not. But after this program, after finish all the flows generating and the log files, we are saving this output actually inside the log file as well. So by comparing this log file and this script file, this script underscore one file, we will be able to compare the accuracy, calculate the accuracy of this real-time classification. So here if you remember, this panel was for host number 2, and for host number 2 3 flows are generated. That's why these 3 messages are shown here on port 1008, 16 and 17. And also we are seeing already the flows are finishing. So let me just show you these other panels for other hosts. So every host actually receiving some flows from host number 1, except host number 6. There is no flow inside that script because we are choosing it randomly. So in this 20 flows there is no flow for host number 6. So that is why host number 6 is not actually getting any flow. We can verify it by opening this script underscore 1 file that there is no flow for host number 6. So once all the flows are finished. So all the flow generations are finished now, and the app is actually still running and waiting for the traffic again. So let me just close the application, and now we can see this log.txt here is generated. And if we open this log.txt, we'll see the output is actually saved inside this log.txt. And we also have this script underscore 1 here. And now by running this runtime accuracy, we'll be able to calculate the accuracy, precision, recall and F1 score for all these traffics predicted by this application. So for that we need to open this runtime accuracy app, and then we have to give the path of this script and the log file here, log.txt, and then script underscore 1. So now if we run this Python runtime accuracy, we'll be able to see the accuracy, precision, recall, F1 score, and also the average inference time for this 20 flows. So we can see the accuracy is 99.59%. So it is pretty good, and so we can see that the app was able to classify the traffic in real time with a good accuracy. Thanks everyone.